In this video, we're going to be reviewing how to solve equations. We're going to look at special cases as well as word problems. So the basic steps for solving an equation is first, a lot of the time if you can distributing is a good first step. After you've distributed, if you can simplify either side or both sides, simplify those sides. Then move your variables to one side and then solve to isolate that variable. So for example, I have 2 times 2 times 2 minus 7y minus 5 equals 111. So distribute. I start by distributing the 2. So when I distribute that 2, I get 4, 2 times 2 is 4, minus 2 times 7 is 14y minus 5 equals 111. I've distributed. Now I simplify, because on this side I can combine like terms 4 and negative 5. So when I do 4 minus 5, I get negative 1. All my variables are already on the same side, so now I can start solving. When you solve an equation, it's kind of like reverse order of operations. When I did the order of operations review, we knew all the numbers, so we just had to follow the order PEMDAS, parentheses, then exponents, then multiply, divide, add, subtract. When you're solving an equation, you're missing one of the numbers, so you have to work backwards to figure out what it is. So you start with addition, subtraction. So I'm going to start by adding 1 to both sides. This gives me negative 14y equals 112. The next thing you're going to do is you're going to divide by negative 14. I get a lot of students that at this point they see minus 14 and they try to add. But this is negative 14 times y, so you must divide to get your answer. And when you do, you get y equals negative 8. Now you can always check yourself by plugging the negative 8 in up here and seeing if you get 111 as a result. Well, let's take a look at this next one. With this one, you can distribute first, or you can get rid of the negative 4 first. It doesn't actually matter which order you go in. So I'm going to start by getting rid of the negative 4. Just because it looks a little bit simpler if you have everything on one line. So anytime you do something like this, you've got a fraction bar, you're getting rid of the denominator. This says that it's divided by negative 4. To undo that division, you're multiplying. I get a lot of students make a mistake here. They try to take the negative 4 and distribute on the top. The only thing this is doing is canceling out the negative 4 on the denominator. So do not distribute, because basically what you've got is 1 over negative 4 times negative 4 that will cancel out and multiply to be 1. That's all you're doing. So we have 3 times 5 minus 3x left over on this side. On the other side, when you multiply these, negative 15 times 4 gives me positive 60. Now I'm going to distribute. 3 times 5 is 15. 3 times negative 3 is negative 9x equals 60. So now I'm going to subtract 15 from both sides, which gives me negative 9x equals 45. And again, same as before, if you've got a negative number right here, do not make the mistake of adding. This is negative 9 times x, so you must divide to get rid of the 9 on this side. So divide both sides by negative 9. 45 divided by negative 9 is negative 5. Alright, next example. This is another one where students will make careless mistakes. You are going to be distributing on both sides. So where students make a mistake is right here. This is minus and then a set of parentheses. What you're doing is you're subtracting both of these terms. So a good way to avoid making a mistake is to pretend there's an invisible 1 here and distribute a negative 1. So 16 minus 7m minus 3. That's the easiest way to avoid a mistake there. On the other side, we're just distributing. So multiply and we get 8 minus 8m. So now we simplify each side. This side I can combine terms with the 16 and negative 3 to get positive 13 minus 7m. The next thing you do is you move your variables to the all to one side. So I'm going to add 8m to both sides. This cancels it out on the right side, and on the left side I'm left with 1m. Now you can write a 1 here, but you don't have to. Last thing is subtract 13 from both sides, and you get m is equal to negative 5. Now in future videos when I'm working out a problem, sometimes I'll combine steps, like I might have combined these two steps into one and just subtracted 13 at the same time I added 8m. But if you prefer having it written out as different steps, do it. Whatever is more easily understood for you, do that. Alright. Now, when you're solving equations, sometimes there are special cases. They don't look any different at first glance, but as you go and solve, you're going to see what I mean. So here, start by distributing. So I have 1 plus 3c on the left. On the other side, I distribute the 5 to get 5 minus 5c plus 8c. I'm going to simplify the right side. So I'm going to bring down the left, and over on this side I can combine my c's. Negative 5 and positive 8 give me positive 3c. Now we move our variables to one side, so I'm going to move my 3c over by subtracting 3c from both sides. But what happens here is 3c minus 3c over here gives me 0, and I've got 1 left over. Same thing over here, except it's a 5 left over. So I have a statement that says 1 is equal to 5. This is not true. If you have a statement that is false, it means that there is no solution. Some teachers will let you write NS or no sol, or sometimes they'll even do this, which is the null set or empty set. It just depends on your teacher. I'm okay with you doing this one. Alright, so looking at the next example. The next one is a different special case. You start off like you would any other equation. I can distribute on this side, so I'm going to distribute. So I have 40 minus 8x equals negative 8x plus 40. Move your variables to one side. So you add 8x to both sides. But just like before, it cancels out your variables on both sides, which leaves us with 40 equals 40, which is a true statement. If it is a true statement, your answer is all real numbers. And you can write it like this. It's the set of all real numbers. That means all your values, all your x values, any of them work. Alright, so equations set up like proportions. If an equation is set up like a proportion, fraction equals fraction, you can solve it like a proportion. When you solve a proportion, you cross multiply and divide. Well, the first step on this is also to cross multiply. So 3 times 2 gives me 6. On this side, I'm going to multiply these. Now be careful, it's not just 5 times x and then plus 4. It's 5 times x plus 4. So you are going to have to distribute. So you distribute the, whoopsie, there you go. We distribute the 5 to get 6 equals 5x plus 20. Subtract 20 from both sides. This gives me negative 14 equals 5x. And then finally, to get just x, you divide both sides by 5. So negative 14 fifths. Although if you do negative 2.8, I will allow that because it is a short decimal. But remember, if it's a long or repeating decimal, put it as a fraction. Okay. This one, same idea. Even though you got variables on both sides, you still work it the same way. Cross multiply. So when I multiply these two, I have 8 times 5x minus 9. On the other side, cross multiply. That gives me 10 times 2x minus 8. Now that everything is on one line, you solve it like the others. Start by distributing. So I get 40x minus 72 on this side. On the other side, I get 20x minus 80. Oops, forgot my x. There we go. Now you move your variables to one side. So I'm going to subtract 20x from both sides, which gives me positive 20x minus 72 equals negative 80. Add 72 to both sides. You get 20x equals negative 8. Divide by 20 and you get negative 4 fifths. You can also write negative 0.8. I'm okay with that too. Alright, now literal equations is something that comes up a lot in science. So a lot of my students are in physics. You might see an equation in physics where you might have to rearrange the formula to get the variable you're looking for by itself. And you do that following the same steps you would doing just solving it for x in a regular equation. Maybe some differences that'll make it easier. Like for instance, on this example, I might not want to distribute that 1/2 just because it's there's an easier way to do it. But it's pretty much the same thing. The difference is you are not going to be able to kind of get rid of or make it look smaller. So let's say I forgot to specify which variable I was solving for. Let's say on this one I am solving for v. Okay? This means I want to rearrange everything and get it to where v is by itself on one side. So I'm going to start by getting rid of the 1/2. Now remember, if you want to move a fraction to the other side, what you want to do is multiply by the reciprocal. So that means you're going to flip it over. So I'm going to multiply both sides by 2/1. This basically cancels out the fraction. So over here I have 14w equals w plus v, because the 1/2 times 2 just gives me 1. Multiplying by 1 doesn't change anything. Now I can subtract w from both sides to get 13w equals v. V is by itself, so this is where I'm stopping, because that's what it asked for, solve for v. Okay. So on this one, let's say I'm going to solve for b. think of if this was like a 2 or a 3. What would you do first if you were solving for your unknown? Well, you would get rid of the bottom number. It's the same thing here. I'm going to scratch that out real quick. I want to get rid of this bottom number. And since it's being divided, you undo the division with multiplication. So I'm going to multiply both sides by c. Now remember, when you have the fraction bar like this and you multiply by whatever the denominator is, all it does is gets rid of the denominator. It does not do anything to the top. So I still have a plus b on the top. And 5c for the right side. Then you just subtract a, and you get b is equal to 5c minus a. So if you get stuck on any of these, just think, okay, if these were numbers, what would I be doing next? Because that's what a variable is. It's a placeholder for a number that we don't yet know. Alright, so word problems is the last thing we're going to recap. When you're doing word problems, pay attention to just key words. Like you might see sum, which means you add. You might see the word difference, which means subtract. You might see the word product, which is multiply, or quotient, which is divide. You might see the word increase, which a lot of the time is going to be addition. Or if it says it's this much more or this much less, that's adding or subtracting. Even the word is can have a meaning in certain circumstances. Sometimes it means equals. So when you go through and read word problems, look for key phrases. Alright, so Tim spent half his allowance going to the movies. He washed the family car and earned $8. What's his weekly allowance if he ended with $17? Alright, we don't know what his weekly allowance is, so we're going to say his allowance is X, because we don't know it. Now, whatever his weekly allowance was, X, he spent half of it. So half of his allowance. But then he earned $8. Well, think about the situation. If you're earning $8, you're adding that amount to what you already have. So plus 8. And after spending the money but earning some back, he ends up with a total of 17. So look for key phrases, or if it's describing a situation, think about what's going on in that scenario. Kind of role play almost, if it's something like this. Picture what's going on. You have a certain amount of money and then you spent half of it. Okay? Okay, I did a job and I got money, so I'm adding to my total. Just think it through. Picture yourself in that scenario. So to solve this, you would start by subtracting 8, which gives you half x equals 9. And then to get rid of this fraction, remember you multiply by the reciprocal, so I'm going to multiply by 2 over 1. Remember, 2 over 1 is just 2. So this cancels out the fraction, leaving us with just x. 9 times 2 gives me 18. So his allowance, weekly allowance, is $18. Sometimes, though, you're not going to have a scenario you can put yourself in, so you might have to approach it a different way. Looking at this next one, I see the word sum. The sum of 3 consecutive integers. Sum is addition. So I know I'm going to be adding something. 3 consecutive integers. Just because I wrote a number 3 does not necessarily mean you're going to use the number 3 in the problem. Be careful on things like that. Now, consecutive means back to back, like 1, 2, 3, 4. Those are consecutive numbers. Or 10, 11, 12. Those are consecutive numbers. Integers tells me I'm not going to have to worry about decimals or fractions. Is means equals 51. So the sum of the numbers is equal to 51. What we want to know is what those numbers are. Well, the first number, we don't know what the first number is. I'm going to call the first number x. We don't know what it is. Okay, so what are we going to call the second number? Well, I guess you could call it y, but if we start throwing other letters in there, it's going to make the problem harder to solve. Instead, think about this. A consecutive number is the next number in the number line. It's one more. So the next number would be one more than the first number. The third number would be two more than the first number. And by writing them this way, we only have one variable to deal with, just x. Now, we know that when we add these three numbers, x, x plus 1, and x plus 2, it's going to equal 54. So let's add these three. Combine like terms. X plus x gives us 3x. 1 plus 2 gives us 3, and it's equal to 51. And now we have an equation that's that we can solve. So start by subtracting 3 to get 3x equals 48. Divide off the 3, and we get an x value of 16. So my three consecutive integers are 16, 17, and 18. The next one is a similar problem, but you do need to be careful and pay attention to all words, because in the next problem, one of the biggest differences is that they're odd numbers. So the sum addition of three consecutive odd numbers, so three odd numbers in a row, like 1, 3, 5, or 11, 13, 15. The sum of those three odd numbers is, that means equals, 135. So we don't know what the first one is. We're going to call the first one x. You could also say n or z or any other letter. I don't care. We're just going to call it x. What you have to be careful of is x plus 1 is not going to be our next value. Up here, it didn't matter whether it was even or odd, it was just consecutive. So let's say my first number is 17 like I had here. The next odd number would be 19, which is 2 more. So it has to be x for the first one and then x plus 2 for the second integer. And then the third consecutive odd number would be x plus 4. This is also true if they were consecutive even integers. So just like we did before, add these three, combine the like terms. We get 3x plus 6. And the sum, when I add these together, is equal to 135. So, just like we did before, we start by subtracting. We're subtracting 6. And we get 135 minus 6 is 129. Then you divide both sides by 3. And you get x is equal, oh good lord, 43. So 43 is my first integer. Add 2 to get 45. And then 47. So just be careful and pay attention to keywords. That's going to be what helps you out the most on word problems. Alright, that's it for this review.